Good morning. We're about to get started here. But before we do, I wanted to bring up something that occurred with Inside Starin, and it concerned our AV over IP initiative. I had our Chief Operating Officer, Bill Pack, ask me, a lot of folks in our company in the warehouse, in the back office, in the order department, etc., don't quite understand what AV over IP is all about. What is this initiative that we have? Well, the AV stands for the obvious. I went about explaining it at a lay person's level for them. The IP, of course, stands for Internet Protocol, and most of us in the business understand that. This is not the official program. I'm going to start that in just a couple minutes, but I thought I would share with you what our explanation was to our own troops about this. So, Internet Protocol, what is a protocol? You have to understand that first. It's the structure of data and how to transfer it from one place to another over a network, right? It's how words in your email get to the receiver's inbox. The data in the digital representation of words is sent that way. In the AV world, of course, the data is sound and visual. So the simple analogy I made to the troops was in the case of sending AV, basically you have where there are frames of video. And those frames of video, if you flip them fast enough, they become motion, right? That's basically cinema, film, and video. So they have to go into an envelope, and that envelope gets sent across the network. And to get there, it has to have a to address and a from address, just like in anything. And it's stamped and it's put into the post office slot for sorting and delivery. And on it goes. Literally, the envelope represents packets or packages, if you will, of your message, your song, video. And streaming is a series of those packets, video frames, combined to deliver the entire content for viewing and listening on the other end. So I wanted to basically show you a little bit of a quick animation I put together so that our folks kind of got the idea. And this analogy of an envelope will become apparent to you as we look at encapsulating how the data is structured into a stream. So good morning, everybody. Welcome to another Starin AV Meetup coffee break. The AV Meetup concept comes originally from our local in-person events that we've had. We've taken folks in the industry from San Francisco, Boston, Chicago, Philly, and other markets out on afternoon boat trips and basically after-work meetups. They were kind of a fraternal type of gathering, but we also showed them some working systems. AV Meetup on the web now has two different versions. The coffee break, where in under the time it takes to sip a cup of joe, we want to cover some application-driven topics, and that's what we're doing today. The second version is actually a web workshop, and that goes deeper into the subject over an hour. Note during this presentation, we've muted the mics to keep the noise floor down, so for questions, please use the chat window, and we will address that at the end. But I think we're going to find that some of the questions that you have will be covered in our subsequent series. So video conferencing began allowing AV over network traffic, and that was the late 90s into this century. But VoIP is really what paved the way for a wider acceptance of the converged network concept as a common reality. So network managers no longer say, "Not on my network," putting up a crucifix, though they are rightfully minded of how anything impacts their mission-critical operations. Especially since we AV folks are sometimes not so specific about what we want to accomplish IP-wise. So Starin strives to help lay a foundation with our AV integrator partners to get more capable and more conversant. At the same time, Starin is equipping itself to work side by side with you so they get maximum, they meaning your customers, get maximum support. My name is Bill Mullen. I'm CEO of Starin, and I'm giving this as a preface today for what will be a series. Professor Phil Hippenstein, will guide us to navigate the LAN landscape and more. Today with me, we'll explore network terms, what they mean to assure secure, effective, and productive results. We'll look at basic network considerations. This coffee break is a preface, like I said, an outline, what will be covered in more depth in the web workshops. So the first topic is bandwidth. It's important, yet at some point, every AV guy has thought network considerations are all about bandwidth. Well, it's important, yet if you think back to when there were 10BASE-T Ethernets, it was very critically important because we had limited bandwidth within the network. So that was a major obstacle at that point in time, so some of that thinking still prevails. But what it's about, it's not necessarily how much bandwidth is used, but it's a bigger part of an equation of network configuration, and how we manage the bandwidth is the objective. So AV over IP requirements have a range of things to consider. This is also known as what IT will do for you to be nice, if you have their info and if you have a basic understanding. So one of the first things to come to understand is the traffic type protocol, the means of transporting or getting through the network, porting your way through the network. And there's two different methods. One is transport control. That's where the C is important in TCP, and UDP, user datagram. A datagram you might just think of as a diagram, or a simple means of structuring the data to get from point A to point B, or point A to point V, as the case might be. And therefore, it has no control within it. TCP provides error-free delivery, but it invariably has some delay. Lost packets can be recovered, which is the good thing. TCP, the control, adapts to network bandwidth. This exchange requires handshaking, and that handshaking is as simple as, hey, are you getting this? And the receiving end does some analysis to say, it looks like we've had some dropped packets. And therefore, it says, hey, no, resend that to us. So this exchange requires that time and can affect real-time media. By the time it's asked for, it's too late. So what AV methods happen to use TCP? Well, HTTP-based streaming, and we'll get to that in a little bit, sometimes called adaptive streaming. And that's found in YouTube, Netflix, and some other serving mechanisms. That's TCP. UDP, on the other hand, is a constant stream and not subject to any network conditions. It has no intelligence in it about what was sent prior or after, so inherently no error correction is going on. It sent a recovery package, so what? It would be too late for real-time media. So the receiving end just is queuing up, send as much data as fast as you can. Now, corporate firewalls may block UDP packets. And that comes from early security concerns where there were UDP attacks. But now today, more advanced defenses handle those threats. So that leaves bandwidth to be a possible concern with UDP, since it is typically a fixed rate. It's not varying itself. It can be more predictable, however, because you know what the rates are going to be. It's more of a given to judge the impact on the network. Some AV over IP developers have designed flow control and throttle data compression into their application. And that might mean reducing the transmission rates or lowering the video resolution to keep that contiguous flow of streaming data going. So what uses UDP? Well, almost anything like a transport stream encoder, an encoder from AdTech that we carry, or Haivision, or others are most likely in that category, including now some professional cameras and other cameras that have an encoder built into them. Video conferencing also is typically UDP. So a second consideration to understand, although it doesn't impact us highly, is the API, and that could be a case of an API identified as HTTP. We're going to move on to the streaming encapsulation, actually, what the protocol is for the streaming. And this has two different areas of interest: real-time transport protocol, and that defines the standardized packet format for delivering the audio-video together in synchronous form. And then there's RTSP, real-time streaming protocol. That can be thought of as a remote control, the start, pause, stop, to control the stream from the server. Now, all this ends up in what's called an Ethernet frame. So far, some of the things we've covered here are identified from left to right in that frame. The Ethernet header, the IP information, basically saying where you're coming from, where you're going to, the TCP or UDP indication, API indication, and then the data, the actually formed media payload that is coming down the pipe, and then, of course, a trailer. Then you have to have a consideration for unicast or multicast. And this is the case for in multicast applications, it's used for non-synchronous endpoint communications. There's no exchange going on. You're sending out, it could be, say, a real-time broadcast, if you will, quote unquote broadcast, although it's a media cast from a technical standpoint. It could be a town hall meeting where I, as the leader of the company, want to get on and everybody's just on a receiving end. It could be in IPTV applications within a hospital where you have on demand and sometimes real time in respect to cable channels that end up on the IPTV network, and the in-room control of a TV or a set-top box that is IPTV capable is controlling what you view. So notice that when you have multicast occurring, program only exists on a particular link in the network if there is an end user, a client endpoint, that has made a request of that. When you have a select group of users requesting that live or stored media to view and not exchange, it's useful for network bandwidth conservation. Instead of the server, the origination point, just serving out to everyone, what's happening is the intelligence is at the router level to decide who gets forwarded that stream. So multicast does increase the processor load of the router. Streaming coding is our next consideration. And now we're no longer in truly the IP data, the protocol area. We are really in the payload, the media area. And this is how the media is encapsulated or compressed. Of course, when we say compress, what we mean is there are mathematical algorithms that take the basic media and reduce it down in its bit size, in its data bulk, and therefore makes it easier to transport. So this is within the Ethernet frame. The thing to keep in mind here is there's various profiles. MPEG-2, for instance, has 6 different profiles. Main and simple are the most common ones, but there's 4222, SNR, spatial, high, etc. And keep in mind, what happens within those is that they may have different purposes. One, for instance, is represented as an extension, file extension, as MP2T. That's a case where when that is used, say within our AdTech encoders, which are often used for heavy lifting broadcast level transport from one place, from the point of origination to a station, from a main campus, a house of worship, or education to another facility. And MPEG-2T is a pretty robust profile, yet may not be able to be played on a Windows media player. So you see that they each have their own purpose at times. And then MPEG-4, the most common, is part 10, 264, 265 is emerging. We're seeing that in places like cinema transport. But the MPEG-4 profile is much more flexible because it's smaller. And what's happening there is the compression is not just across the entire frame, but it's actually within the objects within the frame. So the direction of communications, where you're going from to where you're going to, are very important. And each layer 2 switch has what's called a filtering table containing a destination address and its outgoing ports associated with addresses. So there's this entire matrix, if you will. Think of each switch as a post office or a routing point. And within it, it gets its sorting, and it knows where the zip code happens to be that you're after, the zip code in this case being the IP address that you're after. So direction of flow is important, and of course with that, network addresses, IP addresses are critical to that. And oftentimes they can be either static, meaning a fixed IP address, or dynamic, DHCP it's called, dynamic of course, meaning that it changes with each session. When you turn your computer off and log back on, you'll be assigned a new address, most likely, from the master server, or from the router, I should say. So there are times when we need a static address in AV. How is that? Well, some of our devices actually act as servers. They are a point of origination for streaming. So they may require that fixed address. There's another way to address addresses, and that is in the case where you don't want to use a numerical representation, but you'd rather have a name instead of calling the particular device in a conference room by that 10.0, etc. You want to use a name saying conference room 1, executive conference room, whatever. So that's where you need a domain name server, a server that actually does the translation between your IP numerical address and the name that you desire. The next section is pretty critically important to understanding because oftentimes you need to have the network partitioned, and oftentimes AV devices are in specific partitions of the network, and that can happen from a subnet or VLAN assignment. A LAN is created by a group of MAC addresses. MAC addresses are inherent addresses associated with each piece of hardware. Coming out of the factory, there is a MAC address. Therefore, those in that virtual LAN, the VLAN, only communicate with others in that group, and it's managed by the Ethernet switch within the router. The router that does that is basically called an Ethernet switch, although it's truly a router. So a subnet is created within a range of IP addresses, conversely, versus the MAC address. So subnets are bounded by routers and device interfaces, not by switches. The thing to remember that subnets and VLANs in practical application for AV are almost identical. It's just a method that you're using between the network partitioning. To understand wireless and wired routing, there's a strong movement within AV for untethering. Wireless solutions from Sterin, coming up on almost 4 years ago, this ad that you see here, reduced cable hassles, coring the floor, conduit, millwork. A lot of installation difficulties were circumvented. At the same time, we made the user experience better by not having to worry about what connector and cabling hassles on the table, that sort of thing. So Wi-Fi is now being used fairly extensively, and Wi-Fi access needs to be considered. You have to realize that a wireless access point, a WAP, can be a bottleneck. A WAP has a bandwidth of around 40 meg after you subtract out some of the overhead that is required. And it may not suffice for the amount of streaming going on. And one example I'll give you is in the case of a lecture hall. And in a lecture hall, we had instances of a number of students streaming the content relevant to the lecture. And of course, if we have streams that are up to a meg, you may have an inherent limitation right there of 40 some students. And the best way around that, of course, is add another WAP. So it's a matter of understanding utilization within a space for making sure that the Wi-Fi access is sufficient. Of course, you also need to be aware that the Wi-Fi subnet can get to any targeted devices that are on the wired net and have a separate or different subnet. So firewall configuration is the next consideration, and issues are not whether a firewall can pass RTP or RTSP. It's a matter of how difficult it may be, and this is something to remember regarding working with your IT administrator. He can manage any number of things, but like everybody else in this time, he's busy, or his department is busy. And it's a matter of how much of a pain in the butt it's going to be to do what needs to be done. So the more we can make it succinct and clear to them, the better. The other problem might be is sometimes with an inexpensive firewall. Sometimes the firewalls are not agile enough, manageable enough to handle that streaming traffic in an effective way. So in particular, when it comes to security, they'll want to know about any updating and patching that's going to go on if the device application seeks out an update or if the inherent OS in the device is going to go out and do updates, and how to manage all of that. And then, of course, the area of trust, security, and permitted users is highly important to the IT manager. There's going to be a very particular AV meetup workshop in this series covering this. At this point, I'll just say authentication and authorization are basic security measures in one respect. Authentication, as you might guess, says, are you actually the person that should be on this network? And authorization is how much you're authorized to do within the network. Most security breaches these days are stealing or hacking passwords or the shared encryption key to like Wi-Fi. So most enterprise servers have an authentication, or enterprise systems, I should say, have an authentication server, a radius server might be called, in the enterprise network that handles encryption without that sharing of the key, and that's much safer. So that's just a general glance at the security that we'll be taking a look at in our series. The usefulness of a sniffer gives us an idea of what type of traffic is on the network. It's a packet analyzer, and you could look at VoIP traffic as RTP. Video conferencing is going to come across perhaps in several formats, UDP capable. Sometimes it's with a SSL, secured socket layer, and sometimes IP traffic, IPTV I should say, doesn't use RTP, and both of those might be somewhat misdiagnosed by the traffic analyzer. Security cameras often use RTSP for control, but TCP for the video delivery, and HTTP video. Basically, that is the style of video that is, as I mentioned earlier, using the HTTP protocol. It could be disguised as web traffic. So there's some degree of interpretation that has to come into effectively looking at what's going on within the sniffer. So what if the quality of service on your network is configured appropriately? By quality of service, we mean how you have prioritized the traffic so that everything effectively flows, so that real-time data, real-time streaming is given the priority that it needs to get there in time, and that other areas, other types of traffic gets its proportional allocation. So if that's all fine and well, and from a traffic standpoint it looks good, and you still have difficulty at certain irregularities within a single stream at an endpoint, well, that could be because protocols like TCP might be behaving different with those same network conditions, because over the time of OS clients having updates, changes were made in the protocols. So if one endpoint has an older OS versus a newer OS, that can be a factor. At other times, it might be media latency due to the browser type, or even things like service packs and things of that nature. So what kind of devices are on the network? We're probably fairly aware of things like VoIP phones and video conferencing codecs, video encoders. Devices now, more and more, are having encoders in them. And in fact, I have another presentation that is going to cover how Intel now has encoding at the chip level. So the very computer devices that we have are turning into media origination points of streaming. So cameras and appliances now have a degree of encoding in them. Software on a computer, of course, is another area. Video servers. And those video servers might extend out into digital signage deployments, where the server is serving up an insertion of anything like a news channel or other type of feed that could be going out to the individual players. IPTV, as we mentioned, also could have devices like that as set-top devices. So this is the review, the traffic type, all the different considerations that you take into account. Traffic type, TCP UDP, the application interface, the streaming encapsulation, the type of coding within the streaming, the method of distribution, of course, all of the items we just covered in the network address, subnetting, VLANs, the ports that may need to be opened, and understanding porting and forwarding, wired and wireless routing, firewall configuration, all those come under, how we're getting from point A to point V, and then updating and patch capabilities and that trust and security. So this is probably Guinness World's Book of Records fastest orientation I could think of for AV over IP. It's meant to be brief, and you might be saying, yeah, sure, okay, I kind of get it, great. If you were more quizzical, of course, we're encouraging you to now devote some time to the coming series. And we're going to have all of these recorded, and they'll be on demand. You could turn on some of your associates to it as well. But in conclusion, I want to use my best movie trailer voice here. Imagine a world. Actually, that world is already underway. We're at the state where sharing and collaboration, particularly our content collaboration that the AV industry is most adept and most focused on, has a situation where someone wants to share what's on their device. It goes up to the WAP, over to the routing and switching of the network, and then on to our collaboration station, if you will, and then it gets shown up here on the screen. So what's been expanded upon now is the ability to view the main screen. This is one particular feature that happens to be within Kramer VIA and WowVision products. And at that point, you have the ability to send that main screen over to any other participants, and they can capture that and they can annotate over it. There's an annotation tool for that. So that's kind of a cool capability. So you can see it starts to make the streaming a little more complex. It also allows for the instance of if, in fact, the projector lamp went out, or if somebody's at the back of the room and they can't quite see the length of the room, the detail that is on the screen, they can view their main screen. This also could be a session in the hallway where there is no screen whatsoever. And that's where we're getting to what I've heard defined as that immediate near-field communications. And that's going to be supplementing the physical conference room as we go forward. This is device-to-device connection through the cloud. The change in the office landscape right now that we've already seen in huddle spaces, we might think that that is changing human interaction. But what's really happening is the new expectation in new behaviors are driving those new spaces, that we have mobility and the human interaction from that because we have lack of time for anything. We need to get to fast and relevant connections, and the expectations are there to with demands to get to results and have collaboration immediate. Let's convene, let's confer, decide, keep moving on. Let's not even sit down. So that whole mobile experience is making us very hyper-connected. In this new scenario, a client's device can be a streaming transmitter and receiver. We can share screens, share content, interact, and manipulate the same content together. Go over to a group screen, share it among a group at the same time. Invite others by way of link, by way of GoToMeeting and other things to join that very session in and of itself. So we end up with this really incredible meshed set of AV exchanges happening, and it's going to make for more immediate and collaborative communications. The network deployment is going to become perhaps a bit more complex, and we have to have an understanding of that. AV's role is becoming one really of a productivity partner to the organization, and the IT managers who are with it understand that and see it moving that direction. So we'll be getting closely aligned with the interest of the IT design, and as a result, we're going to be more vital as an industry. So how do you get there? Well, choose vendors that have their documents together. By that, I mean who's going to be able to assist you with the new tools here at Starin, down to our general staff user levels. We're using the collaboration, we're using the tools. Brands that we associate with have excellent documentation. Kramer VIA, WowVision documentation. They have a deployment guide. It's the best that I've seen in the industry. And again, it's something that if you have your basic understanding and knowledge and you can impart that sense of confidence and capability to your IT manager, then you can take relevant documentation to support that and say, here, if you peruse this, if you read through this, you'll get to understand what this device is doing on your network and how it's going to be okay. And we also have been involved in things like the very installations themselves. In other words, the assistance, the design assistance that comes before the job and working side by side with the integrator to have a room like this, which is what you see as a basic educational interactive learning laboratory. We were fairly tied directly to that. We do have some tokens of appreciation. Number one, our AV over IP movement. We've got some shirts for you there so you can proudly say, hey man, I'm getting my stuff together about this. If you were in our session last week and you already have that, we're giving you the new rules of customer engagement. It's a really cool book about how customer expectations have changed. And its biggest redeeming factor, it was written by a guy who's been in our industry. So he's taking some of the social phenomena that's happening and customer expectations and overlaying it into how we as an industry can better address the world and show them what we've got. So I mentioned we have coffee breaks and we have workshops, and here's what's coming up. To extend your knowledge in the basic network education, you're going to want to pay strict attention to the workshops coming up. Like I said, they're in an hour format. So we're going to get into depth on some of the things that we gave you as a briefing tutorial today. In the subnets and VLANs, UDP again, ports, adaptive streaming, RTP, then into the security, then into MPEG transport, multicasting, etc. The coffee breaks are basically, again, more nugget size, 20-minute is what the target is. And these are product featured within IP solutions. And next week, next Friday, Bobby Swartz will be presenting IP notification and intercom, where advanced network devices is active with SIP implementations and HTTP. Were there any questions?